Alright, so a brief little bit of review before we get into the fundamental theorem of algebra. I'd like you to take a look at this function here. Let's list off everything that we know up until this point about this function just based on the work we've done earlier in the unit. One thing that we do notice about this graph, if we were to describe this graph as it moves from left to right, notice that the graph increases, then decreases, and then increases again, changing directions 2 times. What else do we know about this graph? Well, another thing that we've noticed about this graph is note that the arrows go in opposite directions. And because the arrows go in opposite directions, that makes the degree of the function in question here, it makes the degree odd. What we also know is that the right arrow goes up as it moves to the right, so that must make the leading coefficient of this mystery function a positive leading coefficient. However, it still doesn't answer the ultimate question. What was the original function that gave us this graph? All we know is that the degree was odd, and the leading coefficient was positive, so it could mean a lot of things. Not to mention the number of possible terms we could have with this. So once again, we just don't simply know yet. But there is a way that we could figure this out, and the way we need to figure this out, the real key, is looking at the zeros of the function and go from there. And if we look at those zeros, that's the key to actually figuring out just what the function is going to be. And that's kind of what the fundamental theorem of algebra is we can write the simplest function possible with the fewest amount of zeros possible and do a little bit of multiplication to find the equation. Let's see it in action. But before we jump into the fundamental theorem of algebra, let's just do a little bit of practice work for some of the work that we're going to be doing here. Recall earlier in the year we had you factor quadratics. Reminder what the trick was when it came to factoring quadratics. We had to come up with parenthesis groups, 2 binomials when we're dealing with a trinomial like this, and then what we had to do is come up with 2 numbers that multiply together to give you that value right there, 12. And the same 2 numbers need to add up together to give you the middle term in here, which is the 8 for 8x. Now, first times first, when you FOIL backwards, that part's easy. You're always going to pick up your x squared that way. And then this is where that 12 comes into play. You got to come up with 2 numbers that when you multiply them together, you get 12. Now, you only have a few possibilities out here. You got 12 times 1, you got 4 times 3, and you got 6 times 2. Now what we need to do is look at what would happen if we were to add these up. Notice when we add these up, the only ones that add up to 8 is the 6 and the 2. So we're going to use that. And we're going to run with those when we factor here. This should be familiar. You've done this before. So then 6, and then 2. And then what we did from here is the whole zero product property. If we have 2 things being multiplied together, here and here, there's one thing that absolutely must be true. One of those 2 things, either this or that, must be equal to 0. And so then we can solve each one of these individually. It doesn't take very long. We can figure out that x must be equal to -6. And here we figured out that x must be equal to -2. And this is how we went about solving these problems. You know, we could repeat this process multiple times, but really the point I want you to see here is that you guys got pretty good at going in one direction, which was this direction here, starting with the polynomial function and going down here to the zeros. What these questions are asking you to do, and what your job is with these problems, is I'm going to start you off with the zeros, and I want you to work backwards to land at the polynomial functions that you see up above there at the very start of the problem. The key to doing this is understanding that when you look at each one of these 2 factors these 2 solutions down here, notice how you can go up the ladder to arrive at the polynomial. Note that when you look at the x0 being -6, that translates into a binomial factor of x plus 6. A solution of x equal negative 2 translates into a factor of just x plus 2. Once you arrive here, to take it from here up to the final step and get your answer here is just a little simple foiling. Now what you're going to be asked to do here on these problems is do that with more terms. Do that with 3 terms. So what you can see right here is I set up the first step for us already. If you have solutions of negative 5, 1, and 2, your first step is to play the opposite game here and arrive at those factors here of x plus 5, x minus 1, and x minus 2. From there, we're going to FOIL one of these pairs, 2 of these pairs of binomials. So let's FOIL those first 2 right there. So first times first, which is x squared, outside, which would be negative 1x, inside 5x, and last times last a negative 5. Simplifying here with those like terms, negative 1 plus a 5, we arrive now at a trinomial here of negative 1 plus 5, so that gives us positive 4x minus 5. Now it's time to introduce x minus 2 into the party. Now it's time to multiply by one more factor, and the trick to doing that is now using the distributive property twice. Here's what I mean by twice. You have one term here of x and you have another term here of minus 2. What you're going to do with that x is you're going to distribute that x in here once, twice, 3 times. Let's write those terms out. So x times x squared, that's going to give us x to the third. X times 4x, that's going to give us 4x squared. X times negative 5 gives us negative 5x. Now it's 2's turn, negative 2's turn. Let's distribute that in there. 1, a 2, 3. And now note how I write these solutions and think about why I'm writing it this way. Negative 2 times x squared gives me negative 2x squared. Notice I'm putting it right underneath that one. Negative 2 times positive 4x, that would give us negative 8x. Notice I put it in that one. Negative 2 times a negative 5, I know a negative and a negative makes a positive, and 5 times 2, that's 10. Why do you think I arranged this green expression here just kind of down and to the right from the red one? Do you notice now I've lined up like terms for my final step here, which is simply just to combine like terms and write our final answer here. So x cubed, nothing to combine it with. So there's our first term. 4x squared minus 2x squared. Well, that takes us to a positive 2x squared. A negative 5 minus 8 more, we're down a total of 13 x's. And then last but not least is that 10. And so here we've just written our function of simplest form that would give us these answers of negative 5, 1, and 2. Now take a look at this example right here. Notice what's different with this as a fraction. Note what I also left out here is I left out the first step. What was that first step again? Review, review, review. The first job when you look at the zeros is to go and get this expression here with all of those binomials playing the opposite game. Now, as you can see here, the minus 3, that's pretty straightforward. We can arrive at just simply x plus 3. The 1 here is pretty straightforward. We can write that as x minus 1. But what do we make of this 1/2? Well, the trick with handling this 1/2 is I'll give you 2 different routes you can take here. The very simple route you can take is just to simply use the 1/2 the same way you used the positive 3 and the negative, the plus 3 here and the minus 1 here. In this case here, opposite game would tell us that we could just write x minus 1/2. You're more than welcome to do that when you multiply everything out. Just predict what's going to happen, and what you're in for here is going to be working with a lot of fractions here. Now, is that something that's you're okay dealing with? Then great, go ahead and work that out. It's not going to change the first step, which is the foiling. So now for your next move, now it's just distributive property, just like we did up above on the last problem. Let's distribute that x and get all 3 of those terms by moving x here, multiply, multiply, multiply. And then distribute the negative 1/2 here, here, and there. Oops, I see a typo right there. That shouldn't be x squared. That needs to be x to the third. I can see why I had that, because over here in blue I should have had x squared right there. Alright, so now let's distribute that negative 1/2 into those three terms. Alright, yeah, we corrected that one in there too. Now we've got the squares in here. Now it's time to combine our like terms. So then our x to the third, there we go, 2 minus 1/2, that would just be 1.5, right? So we just have positive 1.5x squared. 3 minus 1, that gives us negative 4 x, and then we just have the 1.5 on the end. There's our function. And if you like going down this route with the fractions, be my guest, it works. It works just fine. Okay, so that's what you're up against here on these problems here. So go ahead and give those problems a try. That's really what I'm after here. I'm asking you guys to take these here and turn it into this right down there and get me that final answer.